Okay, so we've got a nice short video, and I mean short video, on differentiation from first principles. What is this thing? Basically, it's one of the things that you're kind of required to know. It didn't used to be on the syllabus until very recently. And it's a bit weird because you get taught it. You don't really get taught too much about the basics, like the ideas behind it, but for some reason they think it's important for you to know. It's very likely to come up at least once, so you should know it. If you want to know why the things I'm doing are true, come and find me. I'm quite easy to find. But this series of videos are all about actually doing things rather than explaining why things in general. So there's that. Okay, so what's the formula for differentiation from first principles? We say f dash of x is the limit as h tends to 0 of f of x plus h minus f of x over h. Now, in class I've explained to you what a limit is. I will use the kind of properties of a limit without kind of, again, rehashing that explanation. A reminder that f dash of x and f of x are a differentiation notation. Now, I led in class with y and dy dx, and I told you f dash of x and f of x fulfill the same purpose in this context. That, as I said, they're not identical. If you remember my last video, I made that very clear. They aren't exactly the same thing, but they fulfill the same purpose in this context. So the example we're running is differentiating 3x squared from first principles. How are we going to do that? We're first going to identify the thing we're differentiating as f of x, and we're going to then work out what f of x plus h is. The way we get f of x plus h from f of x is we're simply replacing x with x plus h throughout. So here, not particularly difficult, replace the x with x plus h. Not hugely difficult, as I said. So that gives us the limit of h tends to 0 of 3x plus h all squared minus 3x squared over h. Expanding this bracket, and I'm relying on you, unless you were actually in my further maths class where I showed you how I do things like this, I'm relying on you trusting my skill that is what it is. If you don't believe me, go ahead and do it yourself. You'll end up in the same place I do. So what did I do there? I expanded 3x plus h all squared. From that first line, we can see that parts of the numerator cancel. 3x squared and negative 3x squared cancel quite nicely. Leaves us with the line below that, 6xh plus 3h squared over h. Cancel the h's, you get the limit of h tends to 0 of 6x plus 3h. Now, if h is tending to 0, then 3 lots of 0 is just 0, so your limit just tends to 6x. And as I'm sure you're aware, the differential of 3x squared is indeed 6x. That's how it works. They can be more difficult ones in terms of just the algebraic manipulation, but the mathematics behind it is the same. And that's where we're going to leave that until next year, when we look at differentiating sine and cos from first principles.